Hi everybody. Today we are going to learn the chapter electricity. So in this chapter we will be covering these topics: electric charge and current, potential and potential difference, Ohm's law, resistance and factors affecting it, resistors in series and parallel, this is very important, heating effects of electric current, electric power and energy. So we know there are different forms of energy. Among this, electricity is very important, and because it is a convenient source of energy that we have. So what do you mean by electric current? Before going to that, just think of water current, wind current, etc. What is water current? Water current means it is the flowing of water. So in electric current, it means the flow of charges is known as electric current. Okay. So let's come to the first topic: electric charge and current. Okay, so what do you mean by electric current? Have you heard about water current, wind current, etc.? So what is water current? In water current, the flow of water is related to water current, and in wind current, what? The flowing of wind. Similarly, in electric current, as per the definition given in your textbook, electric current is rate of flow of electric charges is termed as what? Electric current. Okay, so the rate of flow of electric charges is known as electric current. Now let's go deep into this sentence. What do you mean by electric charges? For this you have to go back to your chapter structure of atom, which you learned in 9th standard. Okay, so you know what is the basic part of a matter? What is the most fundamental unit of a matter? It is atoms. Okay, so what does the atom consist of? It has a nucleus. The nucleus consists of what? Protons and neutrons. Protons are of positive charges and neutrons are of nil charge. Surrounding this nucleus we have what? We have electrons, and these electrons are what? Negatively charged. So can you tell me what is the tendency of the flow of the electrons? See, the electrons are negatively charged, right? So negative charge always tends to flow towards the positive end. Am I right? So the electrons will tend to flow from negative to positive end. So the charge is flowing from negative to positive. Conventionally, the flow of electric current is taken to the opposite direction to that of the flow of the electric charge. That is, the charges are flowing from negative to positive. So the current is flowing from positive to negative. Understood? So the electric current, what is electric current? Electric current is the rate of flow of charges. The direction of flow of charges is from negative to positive. Conventionally, the electric current is taken as the opposite of the flow of charges. So electric current will flow from positive to negative. Please note, this is very important. Okay. Now, have you heard about conductors and insulators? Okay. So what is conductors? What are conductors? Conductors are those which allows the passage of electric current through them. Okay, which allows the materials which conducts electricity or electric current. Okay, or what? Conductors are the materials which allows the passage of electric current through them. And what are insulators? Insulators, It is the exact opposite of conductors. Insulators are those materials which does not allow the passage of electric current through them, which do not allow the passage of electric current. Okay, can you tell examples for both of these, insulators as well as conductors? Yeah, just recollect from your normal life. Okay, so conductors, metals. Okay, metals like what? Iron. Examples what? Iron. Then what? Copper. Okay, mostly metals are what? Gold. All these are conductors of electricity. Okay, and what are the examples for insulators? What are the examples? Yeah, plastic. Then what? Wood. Then what? Cloth. Okay, now let me ask you a question. Is water a conductor or an insulator? Will water come under conductor or the insulator? Water comes under the conductor. Water is a very good conductor of electricity. So water comes under the category of conductors. Okay. Now let's see what is an electric circuit. Okay. Are you noting down all the points which I am giving? Okay. Please note it down. Please prepare your own notes when I am taking the class. It will be very useful for you. Okay. So as of now we studied metals are a very good conductor of electricity. So I am taking the example of a metal wire. Okay. See, this is a metal wire. Okay. It will be consisting of what? Positive protons as well as what? Positive charges as well as what? Negative charges. Okay, so I will denote the positive charges like this and negative charges as a dot. Okay, let all the negative charges be, electrons be denoted as dot. Okay, so this is a static, nothing is happening. This is a metal conductor. Okay, or a metal wire. Suppose I am conducting a cell. Okay, suppose I am giving a cell. Okay, I am conducting a cell over here. Cell is what? It can be any battery, something. Okay, cell will be having a positive and a negative end. Okay, you might have noticed, no? In a battery there will be, if you take a battery you can see one will be positive end and the other will be negative end. Okay, so let this be negative. If I am giving this, I am connecting this metal wire to a cell. Okay, now see, all the charges inside this metal wire will start to experience a force which will compel them to move. So see, these are the negative charges. So you always know like charge repel and opposite charges attract. So these negative charges, it will have a tendency to move which side? This side or this side? See, negatives start moving towards the positive side of the cell. Okay, so this electrons, they will start flowing towards the positive end. Okay, so see, the electrons the negative charge will follow a path like this. Okay, flow of electrons, this manner. Okay, understood? So what will be the direction of the electric current? I told the conventionally electric current is directionally opposite to that of the flow of the electrons. So the electric current will be in which direction? This direction. Electric current. Okay, the flow of electric current will be in this direction. Understood? The charges will be flowing this way and the current will be in this way. Okay, and in many pictures you might have noticed the see, Understood? Now here what can you see? A continuous and closed path of an electric current. You are getting a continuous and closed path for an electric current. So this is known as electric circuit. So what is known as electric circuit? Electric circuit is what? Electric circuit is continuous and closed path of an electric current. Understood? So this is termed as what? Electric circuit. Okay. And see, the cell here we have denoted positive and negative. For convenience, we can denote the same cell as like this. The same circuit. This is a circuit, no? So I am just copying this circuit in a different manner over here. Okay. See. See. Here the longer line will be representing the positive end and the shorter line will be representing the negative end. So whenever you see such a symbol, here this is representing a cell in which the longer line will be representing the positive end of the cell and the shorter line will be representing the negative end of the cell. Okay, understood? Now let's study the formula of electric current. Okay, so let's denote the electric current by the letter I. Okay. So what is electric current? What we have learned? Electric current is the rate of flow of charges. Okay. So let's denote the charge by Q. Okay. What is the meaning of rate of flow of charges? What is the meaning of rate? Rate means whatever quantity we are representing it in accordance with the time. So here the rate of flow of charges means the net amount of charges flowing through a particular area in a particular time. So I is equal to Q by T, where T denotes the time. Okay. So this is the formula for the electric current. That is I is equal to Q by T, where Q is electric current. Sorry, where I is the electric current, Q is the electric charge and T is the time. Okay. Now let's see the units, that is the SI units for the three quantities. The charge Q, the unit for the charge is coulomb. Okay, COLOUMB, coulomb. We represent it using the alphabet C. Okay. Now time, all of you know the unit of time is what? Seconds. SI unit is seconds. Okay. We denote it by small letter S. Now what is the unit for electric current? I. It is ampere. Ampere. Okay. We denote it using the alphabet A. Okay. Now let's study two definitions. One is definition of ampere and the other one is definition of coulomb. Okay. So what is ampere? From the equation you can tell. Okay, what is ampere? When 1 coulomb of charge flows through a circuit in 1 second, then the current in that circuit is said to be 1 ampere. Okay. When 1 coulomb of charge flows through an electric circuit in 1 second, then the electric current in that circuit is said to be 1 ampere. Understood? Similarly, we can write the definition for coulomb. Okay, coulomb. So now you tell me, what is the definition of coulomb? Similarly, from the equation you can see, when 1 ampere of current flows through an electric circuit in 1 second, then the net charge circulated in that circuit is said to be 1 coulomb. Okay, when 1 ampere of electric current flows in a circuit in 1 second, then the net charge circulated in that circuit is said to be 1 coulomb. Okay, understood? Okay, now you got. Now one more question. What is the instrument that is used to measure electric current in a circuit? See, if you want to measure time, you have watch. Okay, like that, there is one instrument that is used to measure the electric current in a circuit. That is known as a meter. Okay, it is denoted by the, so a meter is denoted by the symbol this. Okay, this ammeter is always connected in series with a circuit. I will tell you the reason why in later classes. Okay, just note the ammeter is always connected in series to an electric circuit, and voltmeter is an instrument which is used to measure the volt. We'll study that. Okay, it is voltmeter is always connected in parallel. I'll tell you the reasons why. Okay, just note. See, if you are connecting, I will just denote a electric circuit. Okay, I'm connecting a bulb. Okay, bulb is denoted in the symbol. Okay, connecting a bulb. Then what? Connecting it to a cell. I'm giving an ammeter. Okay, see, the ammeter is connected in series. Okay, the ammeter is connected in series. So what, this ammeter will help you in what? This ammeter will help you in, see, this is the positive and negative. Okay, what is the, which is, this will be positive. See, positive, 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 negative. Which is the path of flow of electric current? Path of flow of electric current is this. Am I right? Okay. So this is one point, that ammeter is always connected. Ammeter is an instrument used to measure the current in a circuit, and it is always connected in series with the electric circuit. Okay. So as per our definition, what we learned? We learned what? 1 ampere is equal to what? 1 coulomb by 1 second. Okay. Now there are, if the current is very small, we use what? Very small quantities for the measurement of the current. Okay, that is what? See, have you heard about microampere, milliampere? Okay, so what is microampere? See, micro is denoted by the symbol this. Okay, 1 microampere. 1 microampere is equivalent to what? 10 raised to minus 6 ampere. Okay, if the current in a circuit is very small, then we use micro, milli, etc. Okay, and what is milli? 1 milliampere. Okay, milli is denoted by this small m. Okay, this is equal to what? 10 to the power of minus 3. 10 raised to minus 3 ampere. Okay. Okay, please note this, because it will be useful for you while you do your calculations, while you solve your questions. Now please note one more point. You know, electrons carry negative charge and protons carry positive charge. Okay, so what is the charge contained in an electron? What is the magnitude of the charge contained in an electron? Just note this, a small point. Okay, 1.6 into 10 raised to minus 19 coulomb is the charge contained in one electron. Okay, and tell me whether this will be positive or negative. This will be negative. Okay, this is what? Charge contained in what? Charge in one electron. Okay, similarly in proton, the charge contained in one proton is positive 1.6 into 10 raised to minus 19 coulomb. Okay, what is this? This is the charge in what? Charge in one proton. Okay, noted. Okay, now let's solve a question. A current of 2 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So, first identify what are the parameters given in the question. Current of 2 ampere. Okay, so current is given. Okay, current is what? I is given, that is 2 ampere. See, you have to check the units as well. It is ampere. So, no need of conversion. Keep ampere as it is. Next, what is the parameter given? Is drawn by a filament of an electric bulb for 10 minutes. Time is given. Okay. Time is given in minutes. 10 minutes. So, what is the SI unit of time? It is seconds. So, you have to convert this minutes into seconds. So, how will you convert? 1 minute is equal to 60 seconds. Okay. So, 10 minutes will be what? Multiplied by 60. Is equal to how much? 600 seconds. Okay. So, you have current as well as time. Now, what is asked? Find the amount of electric charge. So, question is asking what? You have to find the electric charge that flows through the circuit. So, what is the formula? I is equal to Q by T. Okay, I is given and T is given. So, what is Q? Q is equal to I into T. Okay, what is I? I is 2 ampere into what is time? 600 seconds. Okay, so what is the answer? 600 into 2. 600 into 2 is what? 1200 coulomb. Okay, don't forget the unit. Okay, you have always to put the unit. So, what is the unit of charge? It is coulomb. So, the answer is 1200 coulomb. Okay.